Hello, my name is Keshwani. It is K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 126. Please turn to it. Page 126, number 5. The problem that you see on page 126, number 5 is something that we did yesterday, and is the exact same problem that we did long time ago on day number 21. But on day number 21, when I did the problem, I did it at a much slower pace and a lot more details. We are redoing it at a faster pace. Today, the problem that we're going to do actually is not in the book. The problem that we're going to do is something that is not in the book. It's a bonus problem. It's a bonus problem, and it goes something like this. And we're going to do one more after that. As a matter of fact, we're going to do 5 of them all together. The work problem, so-called work problem, we're going to do 5 of them. Today is the second of the 5. It goes something like this. We are told that we have two machines. Machine A takes seven hours to do a job. B takes 3 hours to do the same job. So A takes 7 hours, B takes 3 hours. The question simply is approximately how long will they take to do the job together. If they were to work at their respective paces, how long will it take them to finish the job together if they were to start and finish at the same time, obviously. And here are the answer choices. Two-thirds of an hour, hour and a half, 2 hours, 3.5 hours, and finally 5 hours. Those are the answer choices. Keep in mind that they're looking for approximate answer. But I put it in capital letter. In the real exam, they're not going to be nice enough to you to put that word in the capital letter. You just have to pay attention to it, that you're not required here to do the precise calculation. They're just looking for approximately how long will it take. Now listen, there are two ways we can go about this problem. One is what I call the quick and dirty way, and the other one is a little bit more of a classical way. In the quick and dirty way, what you do is, well, the quick and dirty way that I'm about to describe is not going to be actually very quick. And the reason why it's not going to be very quick is because I have to explain everything. But once you understand it, once you understand how to go about it, it is in fact quite quick. But you just have to understand the logic first. So it's going to take some time to explain the logic behind what's going on here. Here's the logic. Here's our solution. In all of this logic and all of these solutions that we are putting formally on the blackboard, we are writing everything down. In the real exam, all of this thing should take place in your mind, in your head. This is the thinking that you're doing, except you're doing it on the blackboard. But in a real exam, once you master the concept, you will do this thinking on your own very quickly in a matter of a few seconds. Here's the idea. Ask yourself, if the slower guy works as fast as the fast guy, job should take how long? Well, let me explain what it means. The slow guy takes 7 hours to do the job. The fast guy takes 3 hours. If all of a sudden, for some inexplicable reason, the slow guy decides to put a fire under his derriere and begins to work as fast as the fast guy, well, the fast guy can finish the job in 3 hours. If the slow guy begins also to do the job in 3 hours, then now we have two guys working at their respective paces, and each of them being able to finish the job in 3 hours. But each of them individually is able to, if each of them individually is able to finish the job in 3 hours, then together they will take only an hour and a half. Similarly, ask yourself this question. If the fast guy, for some reason, works as slow as the slow guy, for some strange reason the fast guy decided to start working at the same pace as the slow guy, then how long will the job take? Job should take how long then? Well, slow guy takes 7 hours. Slow guy takes 7 hours to do the job. In other words, he will do half the job in 3.5 hours. If the fast guy all of a sudden decided to work at the same pace, now we have two guys on the job, each finishing the job in 7 hours, and they are working together. Together they should be able to finish it in 3.5 hours. There is your range. There is our range of possible answer. So what this tells us is that the right answer, whatever it is, what this tells us is that the correct answer whatever it is, must lie between hour and a half and 3.5 hours. The correct answer, whatever it is, must lie between hour and a half and 3.5 hours. Hour and a half is the best case scenario when we have two guys working there, each being able to finish the job in 3 hours, and 3.5 hours is the worst case scenario where we have two guys working on the job, each taking 7 hours to do the job. And since neither of that actually is true, they are working at their respective paces, which means the correct answer, whatever it is, the final amount of time that they will take will not be as low as hour and a half, and the final amount of time they will take to finish the job will not be as long as 3.5 hours, because the fast guy is in fact not working as slow as the slow guy. So it's going to lie somewhere between an hour and a half and 3 hours. That's how these problems go. Look at the answer choices. Look at the stupid answer choices. Anything that is 3.5 hours or more is ruled out. Answer cannot be D. Answer cannot be E. Anything that is hour and a half or less is ruled out. Answer cannot be 1.5. Answer cannot be 2. Answer cannot be 2/3. That's it, we are done. The answer is 2. That's it, we are done. All of this that we did here on the blackboard should take place in your mind. Always determine the range in work problem, the worst case scenario and the best case scenario, and find out the range as to where the right answer should fall, and based on that, knock out the impossible answers. In most cases, you will be able to knock out 2 answer choices, sometimes even 3 answer choices, and you'll be down to 50-50. At that point, if you want to invest more time in it, finish the problem. If not, 50-50 chance of very good odds, just pick one and move on. Once in a while, where you get lucky, where you can knock out 4 answer choices. Now let's do the same problem a little bit differently. This was the quick and dirty way. Let's do it a little bit. Let's do the same problem in a little bit more of an orthodox way. I need the room, so we need to raise everything here. The orthodox way is where we look for least common multiplier. It is also called the least common multiplier method. Think of a number, smallest number that you can think of, that is easily divisible, evenly divisible by 7 and 3. But that number will be 21. So ask yourself, how many jobs can A do in 21 hours? A can do, well, we are told that A takes 7 hours to do a job. That tells us this tells us that A, we are told that A can do one job in 7 hours. That tells us that in 21 hours A can do 3 jobs. Similarly, we are told B can do one job in 3 hours. That implies that B must be able to do B can do 7 jobs in 21 hours. Stands to reason, because he takes 3 hours to do a job. If you give him 21 hours, he can do 7 jobs. Together, if you put this piece of information and this bit of information together, I didn't mean to circle the top part. If you put this bit of information and this bit of information together, this tells us that together they can do 3 plus 7, 10 jobs in 21 hours. 10 jobs in 21 hours, but they only have to do one job. Therefore, they can do one job. They must be able to do one job in 21 over 10, or approximately 2.1 hours. Well, not approximately, this is exactly 2.1 hours, 2 hours and a tenth of an hour, 2 hours and 6 minutes. Since the question is asking approximately how long will it take them, it should say 21 divided by 10. Since the question says how long will it take them approximately, 21 divided by 10 works out to be 2.1, therefore approximately it will take them 2 hours. That's all. That's it, we are done. Tomorrow we'll do one more problem like this. Tomorrow we'll do one more problem like this, just for extra practice. Okay? Bye now.